Welcome to Chapter 1, Lesson 9, Estimate Roots. So we're continuing with square and cubed roots, but now we're doing estimating because a lot of times we don't have perfect squares or perfect cubes. Legend states that while sitting in his garden one day, Sir Isaac Newton was struck on the head by an apple. Suppose the apple was 25 feet above his head. Use the following steps to find how long it took the apple to fall. Classic science story. Don't know if it was true or not, but that's the story. What is the square root of 5? Well, we know that the square root of 25, is 5. Square root of 25 is 5. Remember this symbol? The formula t equals square root of h over 4 can be used to find the time, t, in seconds it will take an object to fall from a certain height, h, in feet. How long did it take the apple to fall? Well, we have our formula, t equals, and the height we know from the problem was 25 feet. Okay, and we have over 4. All right, well, we know that the square root of 25 is 5, so it's 5 over 4, which means time in seconds, right, is, you could do 1 over 4 seconds or 1.25 seconds. Okay, suppose another apple was 13 feet above the ground. Use the formula to write an equation representing the time it would have taken for the apple to hit the ground. So it'd still be t equals, this time it's square root of 13 over 4. Still same formula. Can you find square root of 13 without a radical sign? Well, think about it. 3 times 3, or 3 squared, equals 9, but 4 squared equals 16. So there is no 13. There's no way to get it there. So no, 13 doesn't have a perfect square. Okay, so that's where the estimating is going to get involved here. What to do when you don't have a perfect square. Estimate square and cube roots. Okay, you know that 8 is not a whole number. Square root of 8 is not a whole number because 8 is not a perfect square. The number line below shows that square root of 8 is in between 2 and 3. Right? Okay, because square root of 4 would be 2 times 2, right? Be 4. 3 times 3, that's square root of 9, but square root of 8 would be somewhere in here. Okay, so let's check. Since the number line shows that 8 is between 2 and 3, since 8 is closer to 9 than 4, the best whole number estimate for square root of 8 is 3. Okay, because 8 is closer to 9. Okay, if you had 2 squared, that's 4, which is not nearly as close as 3 squared, which is 9. So square root of 8 is closer to 9. So if you had to pick a number, you'd rather pick 3 than 2. Okay, so that's basically what you're doing if you have to pick a number. Estimate square root of 83 to the nearest integer. Well, the largest perfect square would be 81. That's less, would be 81. And the smallest perfect square greater than 83 is 100, right? Because think about it. Square root of 81 is 9. Square root of 100 is 10. Okay, so it's in between. Plot each square root on a number line, then estimate. Okay, square root of 81 and 9. Square root of 100 is 10. Square root of 83 would be somewhere in here. And if you did it on your calculator, you could say square root of 83, 9.1. So it's all the way over here, right? Because 9.11. Okay, so it's all the way over here. So it's greater than 81, but less than 100. So it's greater than 9 squared and less than 10 squared. The square root of 9 squared is 9. Square root of 10 squared is 10. So it's in between 9 and 10. And because square root of 83 is between 9 and 10, so square root of 83 is closer to 81 than 100, the best integer estimate for square root of 83 would be 9. So if you had to round, you better pick 9. It wouldn't be as close, but it's not too far off. Closer certainly than 10. Okay, so now with cube roots. Okay, so it's the same thing. Think about what a perfect cube would be. So 6 cubed is 216. 7 cubed is 343. Which is this closer to? I think it's much closer, right? 343, 320 versus 216. I think it seems to be closer. So sure enough, it's between 6 and 7, but it's closer to 343, so 7 is a better estimate. So let's try it. Got it? Okay, you're going to try it. So I'll help you with this one. Let's see. Well, 5 squared is 25, and 6 squared is 36. So which one is it closer to? 36 or 25? If it's closer to 25, you'd write 5. But if you think 35 is closer to 36, then you write 6. Okay, think about this one. Same thing. Cubes. Well, I know, let's see. 3 to the third power is 27. 4 to the fourth power is 256. Excuse me, that's the fourth power. 4 to the third power is 64. So which one do you think this is closer to? 62 and 64 or 62 and 27? So which would be the better answer, 3 or 4? Okay, so do A, B, C, D, E, F on your own. You can pause here and work those out. Remember, I'll popsicle stick call you in class, so be ready. All right, now this one has to do with a decimal approximation. Okay, so it says Wyatt wants to fence in a square portion of the yard. The area covered is 2 square meters. Okay, so how much fencing should he buy? So you need the square root of 2 because you need to find one side. And then we're doing perimeter because he's buying material for the outside. So you'd have to multiply that times 4. Okay, so, Now here they use this ridiculously fancy word, truncating. My gosh. Let's just say rounding. Just means to cut short, truncating. Use that with your English teacher. Okay, it says estimate square root of 2 by truncating or rounding or dropping the digits after the first decimal place, then after the second decimal place, and so on until an appropriate approximation is reached. So if we use a calculator and we do square root of 2, okay, we're going to get 1.4142. So they are going to just try rounding, okay, and just doing 1.4. Okay, and then of course you'd have to round it. You'd have to multiply by 4 because we're doing all the way around. So when they did that, they got 5.6. But when they rounded up, so instead of rounding down, if they had rounded up, they would have had 1.5 and multiplied that times 4. And that would have given them 6. Okay, so they have two options. You want to pick this one or this one. Okay, let's see what they say. To find a closer approximation, expand square root of 2, then truncate or round the decimal after the first two decimal places. Okay. So they did for 1.41. So before they only did 1.4. So 1.41 times 4 and 1.42 times 4 equals 5.6 or 5.64. Okay, so if we're getting closer, I think Wyatt should buy 6 meters of fencing, right? Because you're trying to think, okay, what is the maximum, right? You don't want to accidentally not have enough, right? That would be terrible if you were just as short and the puppy escaped, right? So pick the larger one, right? You want to buy 6. You want to make sure you have enough at all costs. Okay, now this one's a little tricky because it uses pi, but that's okay. If you have a calculator, you can use pi, but you don't really need one because everyone knows that pi is about 3.14. So that's what they're saying. Kelly needs to put trim around a circular tablecloth with a diameter of 36 inches. Use the equation circumference, C, equals pi d to find 3 sets of approximations. Truncate or round the value of pi to the ones, so just 3, the tenths, 3.1, or the hundredths, 3.14. And then determines how much trim she should buy. She'd be multiplying each of these by 36, because that's the D for diameter, and then see which value, what does she need to buy. Okay, so I do 3 times 36. I'd write that down. I do 3.1 and 3.14, and then make a judgment call on about how much she needs to buy. The golden rectangle is found frequently in the nautilus shell. We have this portrait in our math class. The length of the longer side divided by the length of the shorter side is equal to 1 plus square root of 5 over 2. Okay? So find the estimated value of a square root of 5. Okay, well, think about it. 2 squared is 4. 3 squared is 9. Okay, so it's going to be somewhere in between, right? Which one do you think? It says since 5 is closer to 4 than 9, okay, closer to 4 instead of 9, the best integer estimate for square root of 5 is 2. And then use this rounded value. So 1 plus 2 over 2 would be 3 over 2, or 1.5. It's not super close, but if you just needed to make a guess, they want you to make a good guess. Okay, for our drawing today, all this talk of apples and Isaac Newton made me feel a little hungry, so I decided to look up a sketch of apple pie. I said make the dish first, then draw on your crust, then sort of make the rounded shape of the pie, and then put in these like hole cutouts to kind of give it dimension, little dots, the steam wafting, and then maybe some slices of apples just kind of hanging out off to the side. All right, I will see you in class.